So make sure that you have, let me put this in speaker view. I'm not sure why. Is this still showing? Okay, so once you have your signs in front of you, it should say Thursday, March 19th, 2020. That's the one you should have in front of you. Your bodies are now still, and we're working on our connections, okay? I'm gonna, I'm going to share my screen right away with you guys. 1 second. Where is my... Hold on 1 second, boys and girls. Let me just pull up my timer. Back, clear. Okay, I should be able to share my screen now. Yep. Okay, so right now I'm sharing my screen and it should, I'm gonna put the timer on because I know we're still settling in for 2 minutes. So it's starting and you should be working on your connections. And you're gonna show me you're ready by having your hands up.
Miss Nandu, can you make me host?
Oh, sorry, yeah.
Thank you.
Where are you? Oh, there you are. Okay. So we're working on our connections and your hands are up to show me that you're ready. I see Jade is working. Johandi's ready. Jaslene's ready. Yusuf, I do not see you in the camera. Melanie's ready. About 37 seconds. Safwan's ready. "21 seconds. Once again, hands are up to show me you're ready. You have about 11 more seconds to finish up your connections. Okay. All right, so let me put you back full screen. Okay. Okay, so hands are up. I'm scanning to see all hands up now. So Jameer, pencil down. Emery, hands up. Great, okay, so for number 1, it's B. I'm sorry, I was supposed to clap it out, my bad. For number 1, I gave you the answer already, it's B. For number 2, clap once for A, B, C, D. Okay, the answer was B. For number 3, hands up. A, B, C, D. Okay, the answer was A. for number 4. Let me just skip around to make sure. The answer is A. I'm sorry, clap once for A, B, or C, or D. Let's try that again. For number 4, clap once for A, B, C, D. Okay, so the answer was C. And for number 5, clap once for A, B, C, D. Okay, scholars, please make sure that when we're going over answer choices that have multiple answer choices, that you're clapping along, because this helps teachers see if you're understanding what we taught the day before. Okay, or even if you have answer choices during your IP and we're going over it. Okay, everybody should be following along. Yeah.
Some of the scholars are saying they don't have science in their package. Do you know where it is by any chance? 3 scholars.
Mine is Thursday, March 19th.
Okay.
I'm gonna share my screen eventually. I mean,
Okay.
I'm sharing my screen, but I'm gonna pull up the PowerPoint now so they can follow along. Okay, let me just.
Scholars check Thursday, March 19th.
March 19th, yeah. Sorry, it's out of order. The
Okay.
way the packets are. Okay, let me just put this on current slide. Okay, so we're gonna continue with energy today, thermal energy specifically. And our science fact of the day is the sun is millions of kilometers away, but it still controls the temperature of the Earth. Thermal energy is transferred to the Earth from the sun through a process called radiation. Okay, so I know, like in my breakout group yesterday, I believe it was Yandel. He had asked if sun, what thermal energy was sun. Okay, and we said it was radiation. Okay, so this kind of answers back your question, Yandel. So the last time we met for science, we continued our study of energy by looking at how thermal energy flows and travels throughout our world. So what are, so Mr. Vasquez, I believe you're choosing kids, you can just, call on a scholar and they can answer, what are the 3 main ways we learned heat travels?
Joandi?
The 3 ways heat travels is conduction, convection, and radiation.
Okay, can you show me, because I can see you now, can you show me with your hands each of those when you say them?
Conduction, convection, and radiation.
Great, so I want to see everyone doing that. Let's review that. Okay, so conduction, I can't see all scholars teachers, so Mr. Vasquez, I think you're able to see everybody.
Yeah,
So just,
you also have the timer still up?
oh, I do?
Yeah, it might help it. Yeah.
Oh, I guess I have to do new share. Do you see the PowerPoint now?
Yeah, we see facts
Oh,
of the
okay.
day.
Okay, sorry about that. So yeah, just see if everybody's doing the hand motion. So conduction, your hands are together. Convection, okay, and radiation. Great. So everyone, in my view, I can see doing it. That was Nana, Jameer, and Johandi. So great job.
Yeah.
Okay. So in addition to that, what are some examples of how we can feel the transfer of heat in our everyday lives? So based on what Ms. McLean talked about yesterday and some of the examples we gave, can I hear from some, you can choose on like about 2 scholars, 2 to 3 scholars to share out some examples?
Erica?
Way you can see radiation in real life is when you're like cooking and like heat comes up.
Okay, is it coming up? So if we're cooking and it's coming up, is that radiation? Why don't Mr. Vasquez, let's choose on someone to answer her.
We're gonna put
Perfect.
Emery.
Radiation is when the heat is like flowing through the air.
So yeah, it moves outward from objects. Okay, because Erica, I don't believe you were absent yesterday, right?
She was.
Yeah. Yeah, so it moves outward from objects through electromagnetic waves. Okay, so it kind of it's coming more so towards you, whereas if heat was coming out when you're cooking and it's coming up, that's more convection. Okay. So last time we discovered thermal energy or heat travels and flows throughout our world in three main ways, which we said were conduction, convection, and radiation. Okay, so today we're going to pick up where we left off last time and use our knowledge of how heat flows to observe and discover which type of materials best transfer thermal energy. Okay, so the purpose of our unit has been to learn everything we can about energy. And we also have been learning about different types of energy and how thermal energy or heat changes matter and flows throughout our world. So today we're going to continue our focus on thermal energy specifically by observing how heat flows to discover which types of materials best transfer thermal energy. So as we learned yesterday, I'm going to snap and I want to see you do the hand motions after, okay? So heat flows and travels through conduction, convection, and radiation. Great job, Johandi and Erica. I see you guys specifically. So good job. Okay, so let's see how well we remember the difference between the three. So I'm gonna give you, let me do a new share. Okay. I'm gonna do a new share. I'm just gonna give you a minute. Whoops. To just quickly, sorry, I shouldn't have started that right away. To write out the definition, I'm sorry, to match the definitions in your packet. Okay, so I'm gonna just start back. So you have a minute. You guys have that in your packets, right? Because I see some confused faces, so I just want to make sure. Mr. Vasquez, did my timer go away again? Because I don't know when I'm.
You have 17 seconds.
Okay, yeah, because it like disappeared on me. I don't know where.
Yeah, time's up.
Okay, I'm just gonna. There we go. Yeah, it's just weird. Okay. And do you see the slideshow still or no?
No.
Okay.
Just timer.
Just a timer. Okay, so I'll show that just now. So unfortunately, it's not in the PowerPoint, the definitions for each type. So for number one, you can quickly call on somebody, Mr. Vasquez. For number one, it says the flow of heat between objects that are touching is,
Jade?
if objects are touching, what is that?
Jade?
When objects are touching, that's conduction.
Conduction. That's what they said, right? Conduction?
Yep.
Great. The movement of warm liquids or gases to cooler areas is?
Soft one?
Conduction.
And the last one, the movement of energy by electromagnetic waves is?
Nelia.
Okay, so we have to be paying attention.
We have
All
one-
right. Can you call on somebody else?
Yes, Milani.
I don't have the packet.
Oh, you're not back yet. Okay. Well, all right. Rachel.
It doesn't have it in the packet.
It's not in the packet. Okay. Not in the
Okay,
packet.
so even if
Pecan.
it's not in, I'm sorry, even if it's not in the packet, boys and girls, I'm reading the definition, so you should be able to tell me which one of the thermal energies it is.
Okay,
So,
I think it's radiation.
great, it's radiation. Good job, Makan. Okay, so today we're going to take what we learned last time about the way heat flows and travels to determine which types of materials best transfer heat. Okay, so as you can see, I'm in my kitchen because I wanted to do the experiment for you guys. So let me just quickly pull up the PowerPoint again. You can see the PowerPoint, right?
Yeah.
Okay. So from current slide, so our materials are, I have 3 small beads, margarine or butter, an empty plastic cup, plastic spoon, wood spoon, and metal spoon. Okay. So the purpose of our lab today will be to see which materials transfer thermal energy better. A wood spoon, a plastic spoon, or a metal spoon, okay? So to do this, we're going to place 3 spoons made of different materials into a cup of hot water. On the top of each spoon, we are going to place butter and a small bead. So I already did this, I'm gonna show you. I think you guys can see that. I kind of have to hold the wood spoon because it's bigger compared to the other spoons. Can everybody see this? Mr. Vasquez, you kind of have to be my eyes to see, like, with a thumbs up. Just give me a thumbs up if you can see the spoons.
Yeah.
Okay, great. So, and then in the spoon, I already put the little bit of butter and the bead, okay? So what I quickly want you to do.
Ms. Vanhu, can I pause you for a second?
Yeah, of course.
For those of you who can't see, make sure your view's on speaker view, not gallery, so that way you can see Ms. Nanhu clearly.
Oh, Mr. Vasquez, what time is it? Sorry, I can't see the.
56.
Okay. All right. So what I quickly want us to do, where it says, sorry, let me look at my hypothesis. So it says, which material will be the better heat conductor, wood, plastic, or metal? Okay, so I want you to take about a minute to think about and write down which one do you think is going to be a better heat conductor. So do that now. And then show me you're ready by having your pencils down and your eyes back on the screen. All right, is majority of eyes back on the screen? I'm sorry, it's because my laptop is like down,
Yeah.
so I can't really. Okay, great. All right, so all eyes, if you're still writing, that's okay, you'll get back to that. Right now, I want everybody's attention here. And I just want a little disclaimer. I have tried this many times before, and it really depends on how much butter you are putting on your spoon for how long it takes to fall down. So when I was doing it, sometimes the bead would fall down, sometimes it would take longer. But the point of the experiment is to see which one of these is it going to fall first.
Right.
First, and then in the middle, and then last, okay? So I have my hot water and I'm gonna pour it in. So let's watch carefully.
Emery, eyes on screen. There you
Ooh,
go.
so it may take a little bit of time, but while we're waiting to see if it actually does happen, Mr. Vasquez, why don't we call on somebody? Which one do they think the bead is gonna fall from first?
Okay.
The wood spoon, the plastic spoon, or the metal spoon?
Esau, what'd you put for your hypothesis?
So like as I could see, there's less butter on the metal spoon, so I think the metal spoon will fall first, make the bead fall first. Actually, I think it'll be the plastic spoon because it has a lot of butter.
Okay, you can call on somebody else.
All right. Let's see. We got somebody I haven't heard. Lewis.
I agree with Isa because I think it is the butter because I think like the heat is like
Which
I think-
spoon? Which spoon, Lewis? Not the butter. Which spoon
oh
is gonna drop butter first?
I think the metal spoon is gonna fall down.
Why do you think the bead is gonna fall from the metal spoon first?
I think it's gonna fall down from the metal spoon because like the metal it has like the heat is going onto the metal and it's making the like I think it may make the spoon hotter so maybe like the bead will fall down then.
Okay. And you can call on one more person, Mr. Vasquez.
We have, see your hands. Jace.
I think that the wooden spoon is gonna fall first. Like sure it might have more butter, but yet the more butter it makes things like more greasier and easier for things to slide off. And also is that like metal is a strong material, so it'll probably like take more heat in without having without having it to fall, because I know that to burn metal you need 1370 degrees C.
Wow, okay. All right, so it is taking longer. Like I said, sometimes it really depends on the cup that you have, the spoon that you have, different things. But just so we know and just so it's clear, I want you to go ahead while I'm talking about it to fill it out on your charts. So actually, the bead or the butter would melt first on the metal spoon. Okay, so yes, Lewis, you were correct. You can put number 1 in that box. And then it honestly, when I was doing the experiment on the side, between the plastic spoon and the wooden spoon, it was taking a really, really long time. So I wasn't able to see, but I actually looked at another video and I saw that the plastic spoon was then the second one to melt. And then the wood spoon actually happened to be the last one. So in your chart, please make sure that the metal spoon you put number 1, the plastic spoon you put number 2, and the wooden spoon you put number 3. Okay, I'm gonna quickly show you my paper. So I wrote it out, but yeah, you could just put 1, 2, and 3. Okay. All right. So now we're gonna break out into groups. We can break out, let me move the camera up. We can break out for, let's say 8 minutes. When we break out, we're going to be talking about the analysis. I want you to write an explanation of your observations. So what happened during our experiment, then our conclusion, we spoke about it, which material is the better heat conductor, wood, plastic, or metal, and I want you to explain why. And then I want you to make an inference as well. Based on what we have observed today, which material would be better for a cooking pot? Okay, when we have a cooking pot, which material would, out of the 3 materials we used today, which one would be best? Okay, so for 3, 4, 5, 6, 7.
Okay, so we're ready to go into breakout rooms. I'm sending Miss McLean's group is going to be split amongst the 3 teachers. So that way everyone has a pretty even amount.
Miss Diaz, did you press it already?
Doing it now.
Okay, would you be able to change the time to 6 minutes?
Oh, 6?
Yeah,
Ooh,
because it's okay. It's okay if it went through already.
Went through, sorry.
Okay, no problem, no problem.
Okay, so it seems that I have the biggest group here, which is fine.
I'm not in a group.
I definitely put you in one.
So like when you
already sent it?
label it, you also have to select me.
Yeah, I'm still here. So
Me too.
already.
All other scholars, while you're waiting, you're gonna start working on the analysis, conclusion, and inference.
So when I assigned the breakout rooms, I assigned everyone to a specific teacher and then press open all rooms, but apparently it hasn't moved the teachers, and I'm not sure how to do that.
You gotta select us too. Like you gotta type our names too.
Oh, okay.
Yeah. So you can, if you go to do it now, you'll see us in the main room still, and then you can just assign us now to a room.
Okay, got it. I'm gonna close the rooms again and try one more time. So that way the kids aren't there by themselves. I apologize.
No, it's okay. So Emery, I should see you writing on your paper. Good, I see Johandi is working, Ezriel is working, Rachel, David, Sarah, Jason, great job, guys. Ryan, Zamir, you have a question? I can't unmute you. If you type to me, I can answer you, Zamira. Jaden, I don't see you writing anything. Do you not have the packet?
Okay.
Give me a thumbs up if you have the science packet. Okay, so you have it. So why don't you put the charger down and get started on what I told you to do.
Okay, should be fine now. I'm gonna open all rooms again.
Okay, sounds good.
For this time, I'll put 6 minutes.
Okay.
Okay, hi everybody. You're staying muted. If you don't have a packet, it's okay because I'm going to read questions again. So our first one is analysis. What happened during our investigation? Good, Milani.
So what happened at investigation was that the wooden spoon actually was last to drop the butter, but the other spoons were second and first to drop the butter.
Great, thank you, Milani. So what material is the best heat conductor? Wood, plastic, or metal? Go ahead, Madison. Augustine, stop. You're focusing on what Madison is saying.
Plastic.
So you think plastic? Agree or disagree, everybody? I see Liam saying disagree. Liam, why do you disagree?
I disagree because in the experiment the metal burned faster and it fell faster, meaning that the better heat conductor would be the metal.
Okay, everybody, agree or disagree? Jade's saying disagree. Interesting. Why are you saying that, Jade?
I'm saying that because we just did an experiment and we just learned that the metal the butter on the metal spoon melted faster than it was the plastic, than it was the wood. So the better heat conductor is the wood. And also, I already knew wood would be the best one because wood can sometimes get a little rough,
Stop.
and then
You're sitting down
then
and you're
the
listening.
butter won't easily fall.
Okay, so if the butter melts fastest on metal, what does this mean about how quickly the heat is getting to the butter? Go ahead, Emmanuel.
So this means that basically the metal is the best heat conductor because the heat passed through the metal faster than the plastic and the wood. So that's why the bead fell first, because the heat melted the butter and the bead fell down.
Excellent. So pause, everybody. It's actually metal, right? Because if it's melting faster, that means the heat is getting to the butter faster, because in order for it to melt, it needs more heat. So it went straight up on the metal and it made it melt fastest. That means that the wood actually conducts heat the slowest. So now with that in mind, which material would be the best for a cooking pot? You're trying to cook something, you want it to heat up fast. Which material should we use? I want to hear from Brenly.
I think it's metal because most of the times when we're watching videos in science, they use like metals to get the heat in. So
Okay, Brenly, I want Augustine to add to your explanation. Augustine, why would we use metal? Nana, stop. We're not playing around with anything. Pause. I need to see everybody's face on the screen, and we need to be listening to each other while we explain. Okay? Go ahead, Aug.
And did you say why you don't or why you do?
Okay, who can answer? Put up a thumbs up for why we do, or a thumbs down for why we don't. Thank you, Brenly. We're explaining why we would use metal for a cooking pot.
Oh, we would because it's the second one that the butter fell down on, and the first one we should use is plastic.
Marian, I want you to explain which material you would use for a cooking pot.
The material that I would use for a cooking pot is like I would actually use since the metal would have to be like it would go more like in the experiment, the metal
the metal, since the metal is like not the best idea, we would like have to like I would like to use wood.
Okay, I want you to imagine a wooden cooking pot on top of a stove. Someone explain why that won't work and why we should use metal. Go ahead, Jadiel.
We would use metal for two reasons. One, because metal would heat it up real quick, because metal gets hot faster, and wood, when you use wood, the stove is probably gonna make the wood on fire.
Thank you, Jadiel. Right. We wouldn't want to use wood because it might catch on fire. Same with plastic. Plastic would probably melt. Okay. And the key point here, though, is that we're using metal because it is the fastest heat conductor, which we figured out from our experiment. So now we're going to hit the button to return to the main session.
Writing this down. Metal is the best conductor of thermal energy.
Ms. Lorton's group is back.
Now, if you are done with that, I want you to consider, if you want to be safe while cooking, what kind of material would you want to use in a metal pot when cooking? Jade. Oh, I lost you. Oh, Jade, go ahead.
You would use a metal pot because if
Not
you
a pot.
use
What
a
kind of
wood-
spoon would you want to use in a pot when you are cooking?
a metal spoon, because like we saw in the on our observation, we saw that metal is the better heat conductor, so it will absorb the heat faster.
Okay, so I'm going to pause you there. So Jade was correct in saying metal was the best heat conductor. However, though, if we want to be safe in the kitchen, is the metal spoon the best one to use while cooking? Jasleen, I see you're disagreeing. Explain. Unmute yourself.
I disagree with you, Jade. I think that a wooden spoon would be better than a metal spoon because it doesn't heat up as quickly. And with a metal spoon, the metal spoon heats up quickly and you might burn yourself.
Great, thank you, Jasleen. Okay, so it seems that everyone's back, so I'm gonna leave it off to Miss Nehu again.
So I saw that some people were struggling between knowing which one is the best one to use when cooking. And a lot of us realized that, yes, the metal spoon, okay, will be the best one as for like a heat conductor, okay? But it's not gonna be the best one we're actually cooking. Because if I have my pot here, right, and I'm cooking, that heat from my pot is gonna transfer really quick onto the metal, and it's gonna be really hot for me. Same thing with my spoon, the end of my spoon being in the really hot water. If I take it out, if I just go and I pick it up and I take it out, it's gonna feel really hot on my hands that I'm gonna have to drop the spoon away. Okay, so metal won't be the best thing to really use, even though we might end up still using it. It's not really the best thing to use in the kitchen when we're cooking it hot. Okay, so for homework, because we're out of time, right, this ends at 1:15, right?
Yes, this ends at 1:15.
Yeah, so for homework, you're just gonna go ahead and finish the IP, all right?
Okay, so